Welcome back. This is lesson 3 in a series I'm trying to put up for learning programming. That is, the series is mainly for people that have never programmed before. That is, they're just facing programming for the first time. So, if you haven't looked at the previous videos, I've done 2 videos before this one. Most of the things I covered in the previous 2 videos are all about Visual Studio, how to go about starting Visual Studio, how to save or how to create a solution which houses your program that you'll be writing, how to save your solution, how to load back your solution when you start Visual Studio again. So if you haven't done that, I highly suggest you go over those 2 videos and see how to start Visual Studio if you're not familiar with it. So in this tutorial, in this third lesson, what I'm going to look at, we're going to dive into um, coding. So we're going to look at what the structure of a program looks like, and we're also going to look at the basic, should I say, the basics in programming. That's if you know what a program looks like. A program is just a set of instructions. So we're going to look at some sample instructions that you can give the computer. So I'm going to start Visual Studio here, or I will open, if you remember in the previous lesson, we looked at an application we created and we kept it on the desktop inside the My Apps folder. If you double click it, it opens up, and inside my first app, you will see the solution, my first app.sln, that's the solution. So I'll double click that, so it takes me directly to my solution that I've saved. And yes, here we are. I'm going to close this. Now, if you remember in the previous lesson, we saw how immediately we created this solution. It already had these, most of these code inside. It had the namespace, the class program, the static void main. Don't worry too much. Like I told you, don't worry too much about these. We're going to see what they mean maybe later, because looking at classes might not be suitable for beginners, same as namespace. But what I want you to know is that if you remember, I said a program is just a set of instructions for the computer to execute. Now, when you run a program, that is, when you write a program, it's just like you're writing instructions for the computer. And the way the computer runs those instructions is that it runs them one at a time. So it runs the first instruction, then the next, then the next, then the next. If you have a million instructions, it's going to run, well, depending on, of course, there are control structures. So maybe we'll look at control structures later, and you will realize that if you have a million instructions, it's not probably going to run the instructions one after the other until it reaches the million, because somewhere in the maybe instruction number 25 might say, if so and so happens, skip and go to instruction number 500, something like that. So the main thing you should take away is there has to be a starting point for the program. That is, there has to be the first, like a starting point where the computer is going to take the first instruction, and then after that instruction is going to take the next instruction after that. So the thing you should know is that this static void main is like a method. You see these curly brackets, that's, let me just write it, curly, or probably let me use notepad for things like that. So I'm going to be writing some, in case I say something and it's not so clear, the spelling, I'll just write it here. So I was saying curly, curlybrackets, curly brackets. So they're just brackets, but this is what they look like. They're like brackets, but they're not normal brackets. They are curly. They kind of curl in a way. If you look at this, let's get notepad out. If you look at after the static void main, this is a normal bracket, this is a normal bracket, this is a curly bracket. The use of a curly bracket is for scope. Just keep that in mind. We'll look at scope later also. Now inside this curly bracket of static void main, you can see there's this console.writeLine, and then in bracket we wrote doctor's first program. This is an instruction, and this is the first instruction that gets run by the computer. So in C#, inside your static void main, that is where execution starts. So just know that all these ceremony that's been celebrated here, that's what I mean by ceremony, is just all this code that has been written here. Just think of it like it's like preparation for where your first instruction is going to be given to the computer. So what I mean is, let's copy this code. Let me copy that and let me paste that code. Let me paste that code. Where will I paste that code? Okay, anyway, even if I try to paste it here, that would be an error, I believe. Yeah, that would be an error. So let's even assume this is not an error. If suppose you have an instruction here and then you have another instruction here, if the computer comes to run this program, assuming this valid program, even though it's not at the moment, you can see everything here is underlined in red, meaning you cannot write code there. But let's assume there's a valid instruction there and there's another valid instruction here. Know that when your program starts running, it's going to start from here, meaning this will be disregarded and this will be executed as your first statement because it resides inside the static void main. So that is what I'm just trying to get you to understand, is that no matter what volume of code or what in fact, you could have extra code for this same program in another file entirely. This is the program.cs file, which is this here. If you look at your solution explorer, if you remember, I said you can always bring it back from here by double clicking the program.cs, because this program.cs is a file and it is inside this file that we have this code. So you can have other files with more code, all for the same program, but the place where execution starts, I'm still repeating this so that you it sticks in your head. It starts from static void main. Okay, let's just make sure we keep that in our minds, that execution starts in C#, that is a C# programming language. Execution starts from the static void main method. So whatever instruction you write inside the static void main, that is the first instruction that gets run. Good. That is that for that. The next thing I would like to explain is I would like to look at is variable. I know for now this doesn't really make much sense. Okay, for those that or let me say for doctor, which I've done one class with him. I think this would make some sense to him. This is just for outputting Console.writeLine is a method used for displaying something to the user. Okay, so if you write console.writeLine, whatever you put inside these brackets get displayed. I know this all going to sound uh, very alien. In fact, let's just get rid of that. Let me not confuse me. The reason is because there's a certain person I was going over programming. We've had a class on coding already with him. So just to keep everyone in the same page, let's just disregard that class. Let's start afresh. Let's start the class as if we haven't done that. Okay, now what we're going to look at is let's look at you remember I said a program is just a set of instructions. Good. A set of instructions. What makes an instruction? Now, an instruction is just a command you give to the computer. It's an instruction. However, it has to be written in a way that the computer understands. So, for example, now, if I say, computer, make me coffee, notice how almost every single word in this in this statement is underlined with red. Know that that red means the computer doesn't understand what you're saying. So whenever you see a red, it means the computer doesn't. You can see even it pops up with an error message. The type or namespace name computer could not be found. Are you missing a using directive or an assembly reference? This is just a long way of telling you that the computer does not understand what you're saying. Good. Now, it means even though a human can clearly understand this, of course, a computer does not understand this because we have not given it as an instruction that in a format or in a language that it understands. So we know we're going to be writing C#. Okay, so the lessons are going to be basically C#. Now let's look at what are the kind of things or what are the kind of instructions we can give a computer. I would like us to start with we call them variables. Variables. I'm sure you know what a variable is. In English, that is, or in mathematics, you know what a variable is, or you may know, or you have heard about it before. So a variable, like in mathematics, a variable, if you're familiar with maths, is just let's say how do I explain this? Okay, let's say a variable is just like I don't want to use I don't want to use number because a variable is not necessarily a number, but let's say a quantity or a data actually. A variable is just a data, but a data that can change. So a variable is like suppose you have something like a data, but sometime in your program, or let's even remove program from the context, it has tendency to change, or you know it's not going to be the same throughout its lifetime. So while a variable exists, its value, that's the data that it holds, the value of that variable is going to change over time. Okay, so that's what a variable is. However, in a computer, well, there's no much difference in programming languages. In programming languages, also, a variable is just like think of it like a box, made of memory. Okay, a variable is just like a box made of the memory. You can store data inside. Now, the type of data you can store inside that variable is determined by what we call a data type, or data type, like this. Sorry, sorry about that. Data. I hate that. I just, oh yeah, I remember I said we were going to be using Notepad for our jotting. So a data type. Okay, so this is what I was trying to type. A data type is what determines the kind of data that can be stored in a variable. So what that means is, if you have a variable in programming, you can only store a particular type of data in that variable. Okay, well, actually in C Sharp you can, because of the var keyword, you can actually store different types. But for now, I would like, as a learner, just keep in your mind that a declared variable can only hold one particular type of data throughout its life, throughout its lifetime. You keep hearing me saying throughout its lifetime. The reason is because there's what we call scope in programming, and scope determines the lifetime of objects or variables or whatnot. Just about everything in your code, scope is what determines their lifetime. So I was trying to explain variable and data type. Good. Let's see the different types of data type we have in C Sharp. So we have int. There is int. Now an int is just a data type that holds integers. Okay, it's a data type that denotes integers. If you know what integer is, in maths, integers are just whole numbers. So that's something like 0 is an integer, 1 is an integer, 2 is an integer, 3 minus 5 is an integer, minus 99 is an integer. So int is a data type that denotes integers. Now that means that if a variable stores only integers, it cannot store floating point numbers. What I mean by floating point numbers is fractions. So if you declare a variable as an integer, as having an int data type, you will not be able to store things like 3.5 inside. Okay, let's see how we can declare a variable that stores integers. Int, and then you follow the int by the variable name. Now here's the good part about programming. Almost everything you create, just about, well, not everything, but almost just about everything you create in your program is going to be custom. Is going to be like named by you. Like, it doesn't matter what you call it. You can call it just about anything. The only thing you can't call it is reserved keyword. So things like int, static, void, string, all these are, if you notice, in fact, you can clearly see the reserved keywords. They are mostly highlighted in blue. So like namespace is a reserved keyword, class is a reserved keyword, static is a reserved keyword, void is a reserved keyword, string is a reserved keyword, int is a reserved keyword. So that's the good thing about Visual Studio. It highlights, it kind of color codes most of the things you write. So I was trying to explain how to declare a variable that holds integer data types. So what you do is you write int and then a space, and then you write the name of the variable, which can be anything. So for example, I can call it my variable. Okay, this is a valid variable name. Some of you might be wondering, why is it highlighting it in red? Now the reason why it is highlighting the end of this int my variable declaration is because I haven't written a semicolon. Now that's another thing you need to know. In C sharp, after every instruction, you have to terminate. That is, you have to tell the computer this is the end of this instruction. And how do you do that? You do that by putting a semicolon. After every instruction you write, you have to follow it with a semicolon. Okay, good. So int my variable, this is just telling the computer that, please computer, create a variable that holds integers. So like, reserve me a space in your memory. Okay, what I'm going to keep in that space, that's the variable, is going to be an integer. I'm only going to be keeping integers inside that store. And then the next thing you're telling it is that, call that store, that little box you created in your memory, call it my variable. The reason why you name variables is so that whenever you want to access that box that you reserved, so for example, you've created the variable, at some point you would want to put an integer inside that variable, okay, and at another point you would like to pick inside that box and remove what is inside that variable. Okay, so that is why you always name your variables, so that when you want to reach in to that box, you have something you can call. Okay, so whenever I want to reach in, access my the variable I just created, I'll just write my capital VAR, just this name. Once I call this name my variable, it's going to it allows me to access that variable that I stored. Okay, good. So what other types? Remember I said this is a variable. Okay, this is just one example. I said it could be anything. It could also be mx, for example. It could be x, int x. X is a valid variable name. Now there are some guidelines regarding variable names. For example, a variable name cannot start with a number. So for example, 3dfr, this is not a valid variable name. You can see it's underlined in red. You cannot start a variable name with a number. However, you can include numbers in your variable name. So for example, u4f is a valid variable name. Okay, you can have things like rt, sorry, there's no space there, rt 45. Okay, so a variable name can end with a number. Okay, what other thing? Okay, another thing you need to know is that variable names are case sensitive, meaning int rt45, I've declared rt45 as a variable that holds integers. Okay, now if I decide to write something like capital rt45, this is different from this. Why? Because of the capital R here is different from the small letter r here. So this is not this. Okay, so if I declare if I try to use rt45, for example, I write rt45 assign, sorry, that's with a capital R, rt45. I hate when you do that. rt45, and okay, there we go, assign 3 inside. You would notice that I get this red underline, meaning rt45 is not a variable. Okay, because the reason is you cannot just you have to declare a variable before you can use it. Now we declared rt45 here. However, notice r is capital is small letter r here, but here I'm using capital letter R. So this rt45 is different from this. However, if I change this to small letter r, you would see that it works perfectly, because now it understands RT45 is a variable that has been created, and then here I'm telling the computer to store 3 inside that variable. Okay, so I'm just showing you that variable names are case sensitive, so try to keep that. These are some of the things that will trip you as a beginner programming beginner. So always keep in mind that variable names are case sensitive. Now, we've only seen one type of variable. That's a variable that has that stores integers. What other data types are there in C Sharp? Okay, there is float, float. This is another type of variable. This is another type of data type, which means, remember I told you float are for fraction. Okay, float data type allows your variable to be able to store fractions. So for example, rt45 can now take rt45 can now store things like 3.2. Okay, okay, the reason why it's complaining with a red line is because 3.2 cannot just be fed into a floating point number. It's a weirdness of C Sharp. So just keep that in mind, that whenever you write a floating point number, you have to follow it with an F. Otherwise, the computer would not allow you to store, even though it's a valid 3.2 is a valid floating point number. You just have to indicate at the end with an F. I know it's weird, I know it's funny, and it's probably not, doesn't really make sense to me why that has to happen. But anyway, just keep in your mind that for floating point numbers, always end them with an F. The F just denotes that it's a fraction or it's a floating point number. Okay, good. What other types of variables do we have? We've seen data type. Do we have? We've seen int. We've seen float. There is we also have bool. Now, what does bool means? Bool is just short for Boolean. Okay, let me bring up Notepad. So I'll write the spelling for you. So it's just short for Boolean, like this: Boolean, Boolean. What does Boolean? Boolean is just a value that holds true. It's just a data type that holds true or false. Okay, a Boolean, unlike integers where you can hold 0 or 1 or 2 or 3 or 4, or in fact just about all integers. Well, it has a limit, of course, but a lot of integers are possible, can be stored inside an integer. A Boolean, on the other hand, can only store two types of values: true or false. So for example, rt45 can now store, you can store things like true, okay, and then the other thing you can store in rt45 is false, because rt45, we declared rt45 as a Boolean. Okay, these are the only two data that you can store inside rt45. So the value at any point in time in your program, rt45, the value of rt45 is either true or it is false. Okay, good. What other data type do we have? Well, there is string. Okay, so there is string. Now, what does string, what data type, or what kind of data does string data type hold? The kinds of data that string data type hold is just a combination of characters that you can see on your keyboard. Okay, so for example, you can store things like text, Okay, for example, you can store things like GFTYUJ, whatever, blah blah blah. Add some stars, add some brackets, add an underscore, add a plus. Okay, these are all characters that you can see on your keyboard. You can all store inside a combination of them. Any kind of combination of them can be stored inside a string variable, a variable that holds string data type. Okay, now notice that in all the other data types I was showing you the examples, I did not include this quotation marks, double quotes at the beginning and at the end. Now this is what you need to know about strings. Okay, whenever you want to store a literal string into a string variable, you have to start with a double quote and end that literal string with another double quote. The double quote, notice that by the time we store this into RT45, the double quotes are not going to be included. Okay, the double quotes only show, they kind of demarcate, this is where the literal string starts and this is where the literal string ends. Okay, so you can store all type of string. Hello. Okay, you can even store like numeric characters, okay, inside RT45 at the moment, because RT45 is string. Okay, so I think these are the major types of data types. We have other types. Okay, we have data type like byte, we have long. There are just other data types. They're not much, but I just feel that as a beginner you shouldn't need anything more than float, string, int. That's the ones I showed you just now. You wouldn't really need anything more than that. Maybe at some point you would need double to get double precision on your floating point number, but I highly doubt that. I highly doubt that. So just keep the ones we've covered. So I think it might be a good thing to end this tutorial here. At least you've seen how you've seen different types of data types and how to declare variables. Okay, we'll continue from the next class.